Good afternoon, folks. Today we're going to be working on this type of problem in where we require some knowledge about how pulley works. Like, for example, on this case, and as shown here by this man is kind of pulling on this pulley, but that pulley has a rope, and that rope from CA to D is attached to the tree as shown here, making a large angle that would be 20 plus theta, and the small angle is theta. So before tackling this problem, we first need to know how to deal with pulleys. And let me prepare the computer here to do that. Putting my surface on the horizontal so I can work on the details of these. So let's see. So here we are. I have two cases to demonstrate a little bit some of the theory behind a pulley, and not to get that bogged down in all the complication here with so many pulleys, but let's show only one at this point. I have this pulley here, and the question is, like, for example, if I tie that pulley somewhere here and I put a rope like this, so when I put some tension on this rope, like for example a tension T, what's going to happen is that this is going down but this is going up, so we have also the same tension that is here, and that's the that's the principle of a pulley. As long as the pulley doesn't have any friction here, and in the ball bearing or so, that you can rotate freely, then the tension will develop. The tension here, it will be the same as the one tension here. This is going down, but this is going to go up. So it's only a change in direction, but it's the same value, the same magnitude. Then what's the story with this one? For example, let's analyze this. Now that we understand the principle behind a pulley, if I pull down here with a force F as shown on this diagram, that pulley will come down here. So whatever I call F here, they call it tension here. You can call it F as well. It would not matter. The important thing is that they're the same. So in this case, the tension T is equal F. That's what I mean. Now there's another pulley here, and what's going to happen is that tension will develop on this side as well. See, you pull down here, and you develop a tension on this side as well. Now, as this tension develop, then you are pulling down, then what's going to happen that you are also pulling on this tension as well, on this rope. So basically, if I do a free body diagram for that pulley, we end up having, like for example, a tension T going up, another tension T on the rope that is kind of wrapping the pulley. So you have another T here, another T here, and also you have then the weight of the object W. So basically W is being lifted. If I do kind of a force diagram on the Y direction, because it's only Y here that is available, and we'll say that, for example, let's do this, that the sum on this free body diagram, that the sum of all the forces in the Y direction are equal 0. What we are saying is that 3T, 3 going positive up, minus W that is going down equals 0, or that 3T equal W, or T equal 1/3 of the weight of the box. So you have reduced basically the weight of this box by 1/3. That's basically what I'm saying here. So it's the W here is 1,000 pounds. The force that you are on this part of the rope that you're acting on would be then 1,000 divided by 3, and this is where this comes. Here it says here the mechanical advantage for this system is a factor of 3. That's right there. So you reduce the weight this way by 1/3. Now you want to reduce that way a little bit further, then you end up having this contraption here, which is the same story. Like this one pulls down, this will pull up, and that's T, but this will also pull up, and that's another T, but internally this goes into this rope, and you are pulling on this guy as well, but this guy is pulling on this one. So again, if you do a free body diagram, then you have two pulleys like this I'm showing here, then you have a rope doing like this, but internally there's another rope doing like this, and what's going to happen is that this W, all those tension are going in this direction, so that means, and this is connected here just to be sure that they are connected. So basically what you're saying is, if all of them are called T, and T, we know that this T and F is the same value. T, oops, sorry here. So T equal F, right? So basically on the sum of the forces in the y direction up positive, that means that for T equal W, or that T equal 1/4 W. So it's 1/4 of W, and that will be the tension, which is equal to the force that you need to apply here. So that's kind of nice, because that give us an advantage when we do that. And basically from here to here we have an advantage now of 4, as shown here. And you can mess with these pulleys and do many things. Like for example, another kind of setup would be something like this. I have a box like here with a weight W, and I can put, like, let's say 1, 2, 3, 4, and I can put like 1, 2, 3, 4, and I can tie all this guy here. And so basically what I'm gonna do is like this. The rope will go here, then we'll come down here, it will go up, we'll come down, we'll go up, we'll come down, we'll go up, oh yes, and then we'll come down and we'll go up, and we'll tie here. And now this guy is tied to the box, and this tied to the box, and this is also tied to the box, and this is tied to the box. So if you apply a tension or a force F here, then what's going to happen is that tension will be developed between these. All this guy will have the same tension, so that will be T, 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 another T, another T. So what's going to happen is that you have 1, 2, 3, 4, 5, 6, 7, 8, the last one. So you have A T equal W. So basically T is 1/8 of the total weight. So you reduce the force required to lift this weight W by 1/8. So I don't want to say more into this, enough about this pulley theory, but let's go back to the problem. The problem is, let's see where we are. This is the problem. That's what we want to solve. Based on the fact that we know what is a pulley work, the issue is that this is T. We know that, and obviously this would be T as well. Both of them are T, because that's the way they work. So the question is, a man attempts to pull down a tree using cable and small pulley arrangement shown. If the tension in AB, that's tension here, is about 60 pounds, so determine the tension in cable CAD, that's CAD, and the angle theta which the cable make at the pulley. Perfect. So one thing that you have to understand, this is coplanar forces. I mean, it's only forces in that I need to consider in Y and X. There's nothing else, and that's good. That makes life easier. And what we need to do is just do the free body diagram. So we have a force here pulling with a 60-pound force, And there's a distribution here on the pulley that is doing something like this, right? So we have a tension T going that way, and we also have a tension T, but it's going this way. Now, with respect to an angle here, this is 20 degrees, but between them it's about it's about theta. No, I don't have any view. Sorry for that. It's theta. Theta. Oops, missing something here. 20 degrees. That's basically the point. I mean, so with that said, the other item that I need is that this is an angle, and they provide that the angle is 30 degrees. So now I have all the information required to break this into axes, in the y and x axis. So let's work on the x axis. What we have in the x axis, remember that basically what we're saying is that the sum of all the forces in the x axis equals 0, and what we're saying also that in this system in this direction is positive. All right, so with that said, I think that we have the two tensors are going on the left side, so that they're going to be negative. So what we're going to have is that the only one that is positive is this guy. That then, so that would be 60 times this here. That would be cosine of 30, and that's positive because it's going on the positive x direction. Now, on this guy, it's going on the in this case on the negative, but that's going to be this t, which I don't know what it is, so that will be minus t times, now going that direction, that would be the cosine of 20. And then how about this one? Well, this one is a little bit more complicated because it's theta plus 20, so you got minus t times the cosine of, in this case, will be theta plus 20, and that equals 0. That's it. So that's the balance on x. Now the balance on x, the balance on y equals 0, and what we're saying is going up is positive, equals 0. So with that said, is this is going down, but these two are going up. So let's work on these two first. So we got t sine of 20, that's going up, and then we have plus t sine of 20 plus theta, that's going up, minus, then this is coming down, so that would be minus 60, in this case sine of 30, and that would be equal 0. So that's what we got. And the question, how we solve this, how many unknowns that we have? We have two unknowns, that's t, and we have also theta, and there's nothing else. So these are the unknowns, and we have two equations, so we should be able to solve this. The only problem is that theta is inside in some of these sine and cosine, and that would be kind of complicated, and perhaps you might have to have some identities, some sine cosine identities, just properties, just to get this going, and that doesn't look good. So let's start. First of all, let's get this equation and solve this, the first equation for t. So that would be 60 cosines of 30 minus, now t is a common factor, so that would be cosine of 20 plus cosine of 20 plus theta. Close here, and we close here. Now we can break this equation and break it for t, so t is equal 60 cosine of 30 divided by cosine of 20 plus cosine of 20 plus theta. And now the second equation, this one, what we could do is also break for t, so that would be 60 sine of 30 equal, I put this back here on the right side, so we end up having this t as a common factor, sine of 20 plus sine of 20 plus theta. And now breaking for t, that equation is going to be 60 sine of 30 divided by sine of 20 plus sine of 20 plus theta. So that would do, that will work out okay. Now the issue here that we have this equation 1 and this equation 2, they are both equal on the same factor of t and the same variable. So what we need to do is to equal those two equations, and that will look like this: 60 times cosine of 30 divided by cosine of 20 plus cosine of 20 plus theta. That has to be equal 60 sine of 30 divided by sines of 20 plus sine of 20 plus theta. So that still looks ugly. Let's see. The 60 cannot cancel out. The 60 will cancel out, but and I have the cosine of 30 sine 30, that will work out with a tangent of 30 maybe, and but still don't like it. Still, you know what I'm saying? Like, to work for theta now, this is gonna be ugly because theta is in that part there. So cancel the 60, and we end up like something like 1 over cosine of 20 plus cosine of 20 plus theta equal sine of theta over cosine of theta divided by sine of 20 plus sine of 20 plus theta. And so this part here is just a number, so it's 1 over cosine of 20 plus cosine of 20 plus theta equal tangent of 30 divided by sine of 20 plus sine of 20 plus theta. So if I multiply the whole thing, I end up sine of 20 plus sine of 20 plus theta divided by cosine of 20 plus cosine of 20 plus theta, and that's equal to the tangent of tangent of 30. So you can take this part here and you end up with a function something like f of theta equal sine of 20 plus sine of 20 plus theta divided by cosine of 20 plus cosine of 20 plus theta and minus tangent of 30, and that's equal 0. So this is the function that we now need to look for, that value of theta that will make this 0, the whole thing 0. You can do that in Excel or any software that will do that can make a numerical method just to do a 0 of a function. And Let's do that in Excel now, and I will show you how can we do this very quickly. The only thing, remember that when we transfer to Excel, the problem there will be that you have to convert to ensure that everything inside for sine and cosine or anything here, the degree here has to be in radians. So that's the only thing that you have to be concerned, but that's basically it. So let's work the details now, and let's see if we can get to Excel. First of all, let's copy the whole thing. Let's see if we can copy this. We're gonna copy that, control copy, because that's the function that we need. And we go to Excel. Let's close the whole thing. Let's see if I can get to Excel here. All right. Let's pop this big. All right, so here we are in Excel. So let's paste that. That will do. All right, so I got that, and that's the function that we want to deal with. See if I can move it. All right, so we have here, let's call this theta in the time being, and this call the function f of theta. And so let's write the function. So the function is, let's open a parenthesis, so it's sine of 20. Now remember that 20 has to divide it by 180 and multiply by pi. Divided by 8 multiplied by pi. So that will do. We close the parenthesis, plus sine again of 20 plus, but careful here that 20 plus theta. Now the whole thing that need a parenthesis because it's going to be 20 plus theta, and then that theta comes from here, so we put those two together, and then we divide by 180, and then we multiply by pi, and finally we close another parenthesis, and we have one more to go. There we go. And then basically divide by the same thing. So this is what we're gonna do. We're gonna copy the whole thing up to, I believe, up to here. Copy, and then we're gonna put all that here. Now except that instead of sine here is cosine, and instead of sine here is cosine as well, and that look good. If I screwed up, let's see. Still something is not right. Let's figure out what might that be. Sine. I got here cosine. That's look good. How about the sine here? That doesn't look good. Oh, it's called. This is Spanish language. Damn. Holy cow. Seno. So don't wonder. Sorry for that. It's called seno. This is Spanish. This Excel is all. So cosine is okay. Yes, that's okay. There we go. And that's when theta is 0 here, right? All right, so let's go back here to finish this. Minus tangent of 30. Now That 30 need to be fixed as well, so that's divided by 180 multiplied by pi, and then we finish here. Good. So let's see this work now. Oh brother, so I gotta use the seno instead of the sign like a regular Excel for so this is in Spanish. So let's get 10 degrees and let's see where we take this. All right, about 20 degrees. It's getting smaller as if I move. Let's see. Actually, 20 degrees it hits a zero, meaning let's see, let's get one closer. 19 is pretty much zero, so 19.5, yeah, definitely it's moving to 20 degrees. So it's kind of funny, this problem, it end up having the same degrees on theta, so that's what's happening here. So we end up that theta is 20 degrees on this problem. And interesting, let me hold it here for a second. So kind of interesting, end up being 20, which was basically, we go back to the problem, 20 was as well this one here, so you end up that this one is going to be set at 40 from here to here, or 20 between them. And going back to Excel, as you can see, I kind of it wasn't a difficult problem, because basically you end up in kind of a not, very, very decent number, nothing very complicated. Now there's another way to do this. I was doing here more like a try and error, like for example, puts a number and let's see where this will take you. And so the 20 definitely will take me to 0, but you can certainly do this now that you're in Excel, very straightforward, by using, like for example, let's see, solver from Excel. I have some videos about how to use solver from Excel, but this is not particularly for this course, so I will not talk too much about it, except that I'm going to use it just to confirm this 20 degree here on theta. So let's say solver here, let's call them up, and what I need to do is to what is my objective? My objective is to take this equation here, this one, which is, and we want a value of 0, and by changing what? By changing this guy. And so I'm gonna be gonna take this, not that it's required this problem, because I know that the answer is a positive number, but sometimes you don't know the answer, so you want to take that out. And maybe nonlinear is perfect for me, no problem there. And anything else? No, just solve, and let's see what the system will do. And we're gonna call so we're gonna say aceptar, so that's meaning it's okay. And you end up with the 20 back again and some error here. So I might be able to run this a second time just to get some improvement. The theta is pretty much 0 here, the function of theta. So let's run a second time. Let's call solver again for the second time. I don't have to change anything, and resolve again, and let's see if I do any changes. Actually not, but we can do again solver, and let's see what are the options here. And the option is precision restriction. Let's add a few more 0 to this, and let's aceptar, and let's run this again. Let's see if I get any better. Okay, let me go back here. Did I change something? Yeah, unfortunately I changed something here that is this. Okay, and that look good. 0. Resolve that. And yeah, now accept that. Finally, I got something that is definitely a 0, and I got the 20 degrees, which I already know from my trial and error. So bottom line, that's 20 degrees. So with 20 degrees, then we go back again to our here, and we are ready to get this problem wrap up. Again, I use solver, or you can use trial and error. So let me get this in the right position so I can work this out for the final numbers. And so we close this. So what we got? We got that here theta is 20 degrees. Now, with that said, we can go back to my two equations, like for example, either the one at the top or the one at the bottom here, equation 1 or equation 2, and we can calculate the t. So let's do that. Let's copy this one here. Copy. Why? I'm not sure what's going on, but something is not right. It's not there. There we go. So, and from there, let me see if I can write. The final answer is you substitute this 20 right here, and then you get the t. So the t is gonna be something like this, 60. Whoa, I need to change the position because that looks very ugly. See if we get this get better. So t equal 60 times the cosine of 30 divided by cosine of 20 plus cosine of 20 plus 20, that's 40. So t equal, now let's get my calculator, can do that on also in Excel, but let's use the old style using my TI. So what's this? So that's 60 times the cosine of 30 divided by the cosine of, oh, there's something, did I put this right? Cosine of 20, there we go, plus the cosine of 20, plus the cosine of 40, and we close the parentheses, and the final answer is t equal 30.5 pounds. So that's t. Sorry for the computer in the last minute, it's kind of failing to write properly, but that's basically it. So that's the end of the problem, and it was kind of I would say it is this function that makes this problem a little bit harder, because in essence coplanar forces are easy to deal with in both x and y direction, and so we were able to put this equation in terms of t and equal them, and when you equal them, then you end up with this function for having equal to 0, as shown here, if theta equals 0. Anything else here? I guess that this kind of wrap up the problem. So as always, have a great day. Bye.